Hi everyone, welcome back to Coding with Bharat channel. So, as you know, this week we are covering 2D prefix sum as a concept, and let's go ahead with another problem on the same concept, which is this problem stamping the grid. So, again, a problem which is asked in a lot of companies. Like I personally have seen and asked this problem once or twice, right? So yeah, a good problem to take a look at, and more importantly, a very good problem to re-establish the concept of 2D prefix sum. So let's get started. So the problem says we are given an m cross n binary matrix. Okay, so an m cross n matrix which is binary, so zeros and ones are there. Now, apart from that, you are given infinite stamps of a particular dimension. So what is a particular dimension? The stamp height into stamp width. So let's say 2 into 2, or let's say 2 into 3, whatever it could be. Okay. Okay. In the binary matrix, it says 0 means that particular cell is empty. 1 means that particular cell is occupied. Okay. Essentially, what we want to do with these stamps, we want to cover all the empty cells. So we want to make sure that all the empty cells are covered using our stamps. There are certain restrictions and requirements. Let's read through all of them. So first is obviously we want to cover all the empty cells. So even if one of the empty cells is left out, then it would not be a good idea. Second, we cannot cover any of the occupied cells. So the stamps should only cover the empty cells and not the outside cells. Third, we can put as many stamps as we want. So there is infinite stamps and we can put as many as we want. Stamps can overlap with each other. Very important point. So it can happen that one stamp covers 4 elements, which is 2 cross 2. Another stamp shares 2 of the elements with the first stamp, or just one corner with the first stamp. All those things are possible. Okay. Stamps are not allowed to be rotated, so we cannot do height into width instead of that width into height. That is not allowed. And lastly, stamps must stay inside grid. So it cannot happen that, let's say, if there are just 2 elements, 2 zeros in the corner, to fill it with the stamp, we cannot let the stamp go outside the grid. Okay, let's take some example and see this more in a action. So let me take a binary matrix to start with. So let's say I start with 1 0 0 0, and here also let me take 1 0 0 0. Let me take 1 0 1 1. Yeah, let's say 0, or let's take 1 here, right? Let's take 1. Okay, so I've taken this example to illustrate all the possible scenarios, right? Okay, so first of all, two stamps can overlap, and let's say our stamp size is 2 into 2, right? So it's a 2 into 2 stamp that we are using. So what we can do, we can place a stamp here, and we are allowed to place another stamp here. This is very well possible. So this is not a problem at all. Second thing, we cannot take and place a stamp here because there is one occupied cell that we are going to cover. So that is not allowed. We cannot cover a particular one. Okay, let me also make this as 0 to take one more case. Lastly, even this kind of placement is not allowed, where only 2 are covered and 2 others are outside the grid. That kind of placement is also not allowed. So in this case, the answer would be no, because at the end of the day, we are not able to cover all the cells. But if the case was something else, like if all these were zeros, then it would in fact have been possible. So cover these 4, cover these 4, cover those 6 as well, and we are done. So you need to return true or false, whether you can do this, whether you can cover all the empty cells with stamps or not. Okay. So just pause the video here for a moment and think if you can come up with a solution, right? And see if, yeah, any brute force also comes to the mind. Okay. Great if you were able to think. So first, first step that comes to my mind is let's try to see where all we can place stamps, right? That is the most important point. Let's try to see at what all places we can put a stamp. So can we put a stamp at this place? How do we check that? We would need to look at the height and width of the stamp, those many rows and those many columns. Do all of them have 0, right? So we have 2 into 2, so 2 rows and 2 columns, they all have 0. So answer is yes, I can place a stamp here. Okay, similarly for the second element, are 2 rows and 2 columns having all 0? Yes, so I can place a stamp here. Third element, are all 2 rows and 2 columns having 0? Answer is no, so I cannot put a stamp here. Similarly, here again cannot put because 2 into 2 doesn't have 0. Cannot put because 2 into 2 doesn't have 0. And again here cannot put. Here I can put, again no, no, no. Actually here it would be yes because we can make these 4. Similarly here also it will be yes because we can make these 4. Again no, no and no. So basically for any I comma j, if I want to check if we can make this as the top left of my stamp, then what I would need to do, I would need to check those many rows and columns as equal to the stamp height and width and see if all of them are 0 or not. So I'll get to know, okay, these are the places where I can place the top left of my stamp. Okay. Now that we have these places, what I can next do is place the stamp and mark all of them as 1. So what I'll do is, if I place a stamp here, this will become 1, this will become 1, this will become 1, this will become 1, or occupied. Similarly, second position I can place a stamp. So again, this will become 1, this will become 1, this will become 1, this will become 1. So in a way, you'll see everything gets covered. Similarly, if you do the same steps for these 3 also, you'll see the entire grid getting covered with 1s. So 2 steps. First, for each position, see if you can place a stamp there and note down all the places. Second step. Second step is go over all these places where you can place the stamp and mark that particular submatrix as all 1. And then in the end, see if everything has been converted to 1 or not. Okay. Let me talk about this brute force idea and its time complexity. So step 1, which was there, let me just clean it. So step 1 was what? Step 1 was at every position. Every position. So how many positions are there? N into M positions, right? So for every N into M position, you would go width into height and check if everything is 0 or not. So in a way, iterate and check if it's 0 or not. So in worst case, again, you would have to go N into M. So the complexity will become N square into M square. Similarly, second step, which is wherever there is 1, so there, it can happen that at every place we can place a stamp if everything is 0. So again, N into M places, you can place a stamp, and then again N into M to make it all of 1. So even the second step is N square, M square. Last step is to check if everything is 1 or not. That is actually N into M. So last step is fine. Last step is within the time complexity. But the 2 steps, first to check if at a given position we can place a stamp or not, that is N square into M square. Second, when we know, okay, these are the places we can place the stamp on, marking those submatrices 1, that is also N square into M square. So let's solve both the problems one by one. Okay, let's start with the first problem. If I am at any position I comma j, right, let me just clean it up. If I am at any position I comma j and I want to know if the stamp can be placed as placing top left here, what do I need to look? I need to look if that submatrix has all 0 or not. So just think about it. Can't we use our prefix sum logic to actually note down if some of this submatrix is 0 or not. If sum of that submatrix is 0, that means all are 0, because we have 0 and 1 only. We don't have minus something. So using our same prefix sum 2D logic, we can quickly get in O of 1 what is the sum of a given submatrix, right? So now our n square into m square becomes n into m only. Why n into m only? Because at every position now we'll in O1 know if all are 0 or not, and we can note down those positions, right? So that is the first idea of optimization. Okay, let's talk about the second problem that we had in hand. So let's say now we identify that these are the positions like 3 and 2, 5 positions where we can put our start of the stamp. Now, how to make the corresponding values 1, right? How to make the corresponding values 1. Okay, so I'll say one more thing. Do we need to actually make it 1, or do we just need to know if that place will become 1 or not? If you think about it, we don't actually need to make it 1. We just need to know what all places will become 1, right? So let's hear it out one more time carefully what we mean here. So what I can in fact do is, if this stamp is being placed here, what I can do, for I can just change the top bottom right value to 1. Okay, or make a separate matrix actually, and put this bottom right value as 1. So yeah, similarly when I place this stamp, this is the bottom right value, I'll make it 1. Okay, what is the benefit of this? Now if we want to check if this place will become 1 or not, what do we need to check? If any of the stamp was placed, any of the stamp had bottom right in the corresponding segment, right? I'll tell again what I mean here, right? So I'll take another example for that. So let me take 0 0 0 0 0 and 1. Okay, and let's say we have some more ones here. Okay, so now what I'm doing is, at this 0 I check. Okay, 2 cross 2, is it all 0? Answer is yes. How? Using prefix sum. So answer is yes. So I'll mark at this particular position 1. So I have another matrix having all zeros. So 0 0 0 0 0 0 0 0 0 and third row. I'll mark this as 1. So this will become 1. Next, I check next element. Is it all 0? Answer is no. 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 So I have only one single one. Now, if this position is the bottom right, then to know if any particular position has been changed to 1, like for example, this position has been changed to 1, I just need to look at again the same submatrix. If any of the stamps end in this particular domain, because if any of the stamps end in this domain, so let's say when I am checking this particular position, I am looking at these 4. If any of the stamps end in these 4 places, then that means those stamps will cover me as well, right? If I'm at x comma y, if any of the stamps are ending at plus stamp width and below stamp height in this region, that means those stamps will cover me, enclose me, because they would be going back either before me or will be ending at me. So that is the same idea. Again, prefix sum comes into picture again. Like if sum of the submatrix in new matrix is greater than 0, greater than 0 means any one stamp at least would be ending in that domain, and that stamp will cover me as well. So yeah, twice prefix sum. First to check, once we check, we mark the bottom rights as 1 in a new matrix. In that new matrix, you again take prefix sum so that you can check at a particular position. If any of the submatrix have 1, that means this will be occupied by that stamp. Okay, so let's see this quickly in action in form of code as well. Slightly tougher problem, so just take some moment on copy pen and try to figure it out yourself as well. Specifically the second part, right? I'll give you an analogy for the second part quickly. If for 1D array, if that becomes easier to understand. So I'll give an analogy of 1D array, that how a similar thing would look at 1D array. So in 1D array, let's say what happens. You say that you have sticks of length 3. You have sticks of length 3 with you, right? And you are placing them on certain elements. Okay. So if I mark out that, okay, this is the place where you are placing a stick. Let's say this is a place where you are placing a stick. Let's say this is a place where you are placing a stick. These three are the places. So if I want to check at any place if a stick would cover it or not, then what I would need to do? I would need to look at the next three elements and see if any of the sticks end in these places. Because if any of the sticks end at, let's say, me, so that means I am covered. If any of the sticks end one step later, then also that stick would cover me. If any of the sticks end 2 steps later, then also that will cover me. But if it occurs 3 steps later, then I will not be covered. So the simple idea that you put +1 at the endings, +1 at the endings, take prefix sum, right? Take prefix sum, and then when you take sum of this subarray, that will tell you if it's greater than 1, there is at least one stick which is being placed covering me, and if it's equal to 0, that means all are 0 and there is no stick covering me. So same idea we are using with 2D. The stamp is just covering things in 2D. So we are putting at the bottom right, and with that we are covering the previous elements. So at any element we just need to check if the area after it has any of the stamps ending at a particular position, at those particular positions. Cool, let's go back to our code quickly. Submissions here. Okay, so I have just copied prefix sum function that we used in previous problem when we discussed the prefix sum concept, right? I'll just repeat it. So what we do row wise sum, we do column wise sum. So when you do row wise sum, column wise sum, you get the prefix sum. I have also copied the sum of region, that if R1, C1, R2, C2 are given, how do you calculate sum of the region? So you calculate sum till R2, C2, subtract the sum with R1 minus 1, C2, R2, C2 minus C1 minus 1, and then you add back the top left. This idea we have covered already in the previous video, like the video that just released yesterday. Okay. Now let's look at the possible to stamp function. This is the main function that we have added right now. So what I've done, first I've calculated the prefix sum on my grid. So I've copied the grid into prefix sum, calculate the prefix sum. Right? So this will store the prefix sum. Now I have created a marks array where I will mark the bottom right position if a particular stamp can be placed on this particular position, right? So if at I comma j I realize I can place a stamp, then I'll look at its bottom right and mark that. Okay, so let's see that in action. So I equal to 0, so grid dot size, j equal to 0, grid 0 dot size. So going over all the elements, find out the bottom right x and y. So bottom right x would be I plus stamp of height. So stamp of height minus 1, I plus stamp of width minus 1. Right? Why minus 1? If you are at 0th position and your stamp width is 2, then you do 0 plus 2, so you'll go 0, 1, 2, like 3 will be enclosed. But actually you want 0, 1 only because size is 2, right? So minus 1. Okay. If the bottom right x or bottom right y they go beyond the grid, then you break. This means that that stamp that you are trying to place is overflowing. That means that is overflowing the grid. Okay. Otherwise, find the sum of this region. If it is 0, if it is 0, that means we can place a stamp here and I'll mark the bottom right. So marks of bottom right x, bottom right y equal to 1. So look at every position, see if you can place a stamp. If yes, put a stamp or put a mark at the bottom right. Okay. Now I've done prefix sum on this marks, right? Prefix sum on the mark. Now again, I'll go over all the elements, calculate bottom right, bottom right, bottom right x, bottom right y. This time, if something overflows, right? So for example, if I go back to my screen, if there is a 0, let's say in these 4 positions, right? So when you are checking for this position, what do you need to check? You need to check that if there is bottom right of a stamp in this region, but that region goes beyond, so you will restrict it to the range of the grid. So that is why if you see in the code as well, I have written bottom right x is minimum of grid dot size minus 1 and the value that you get by I plus stamp of height minus 1. So yeah, if it goes beyond, then you restrict it to the n minus 1. Similarly, if y goes beyond, you restrict it to m minus 1. Okay. So if the current position had 0 in the original grid, if the current position had 0, that means we need to change it to 1 and we need to check if the box below it has any of the stamps ending in it. So what I do, I calculate the value or the sum of region in marks from I comma j to bottom right x, bottom right y, and see if the value is 0, then that means this position was not covered by any of the stamps and I'll return false. So return false directly. If all of these satisfy, then you simply return true. So that is the idea that got us through doing prefix sum, 2D prefix sum twice. Once for checking if all are 0 or not. Second for checking how many stamps end in that particular region. Okay, great. If you were able to code with me and understand this problem well, do like the video, subscribe to the channel if you found it helpful, and do share it with your friends. Let's see you guys tomorrow. We'll take up one more problem on 2D prefix sum. Let's do this topic very well by the end of this week. So let's see you guys tomorrow.